Alright, good day. Hope that you're doing well. So in this video, we're going to be starting off with Euclidean geometry exam questions from your November 2023 paper. Now we're going to start with question 9, right? Question 9 requires us to prove theorem 2, right? Basically here, we're required to prove that our angle at center, which is this angle, is going to be twice the angle at circumference, all right? So here, whereby I have my other circle, this is where I'm going to do all my workings, right? In order to prove this theorem. Remember, this is what we are required to prove, right? That this angle is going to be twice this angle here. All right, now let me go about doing that. So first, I'm going to start with my construction. So what is it that I'm going to construct? I'm going to construct diameter PK, right, passing through center O, right? Diameter PK. Obviously, your diameter would pass through the center, but I'm just going to specify this passing through center O to form O1 and O2. All right, now let me go about doing that. So this is my diameter. All right, and as a result, this would form O1 and O2 this side, right? And this is my point K. All right, now let us get to the actual proof, right? So now proof. So the first thing that I'm going to mention, right? So I'm going to say, okay, let OPR, which is this angle here, right? Let OPR be equals to X, and the other angle on the other side, which is, so let me write this here, let QPO, right, which is the other angle on the other side, be equals to Y, right? So let me go about naming them on my sketch. So this here is X, and on the other side, this is Y. All right, hopefully that is visible. So, okay, now let me go about proving. All right, so now I'm going to name the triangle that I'm going to be working on. So the triangle that I'm going to do my workings on is triangle OPR, which is that triangle which has your angle X, right? So basically triangle OPR, this is where I'm going to do my workings. So I'm going to name it here in triangle OPR. So first I'm going to start by saying OP, which is this line right over here, is equals to OR. Now, why is that? Both of these lines are your radius, right? Remember, your radius is that line from center to the circumference of the circle, right? So as you can see, your O starts from center and then it goes to your circumference, which is R. Same applies here. It starts from center here and it goes to your circumference, which is at P, right? So here I'm going to say OR is equals to OP. And my reason would be radii, right? Because both these lines are radius. So as a result, this is equals to that. Now, can you see the type of triangle that is being formed here? It's an isosceles triangle, right? Now, as a result, if this is an isosceles triangle, this simply means that this angle R, this is going to simply mean that this angle here is going to be equals to your angle here, which is P, right? So as a result, angle R is going to be equals to angle P, and both of them are going to be equals to X, because why? Your P is equals to X, right? And the reason here would be, so your reason here would be angles opposite equal radii, right? So angles opposite equal radii, right? So now, or you could just say angles opposite equal lines, all right? So it depends on you. So now this here, it's also X, all right? Now, also, I want you to note something, right? So now if you look at this angle here, O1. Now, O1 is an exterior angle of a triangle. And remember, your exterior angle of a triangle, it will be always be equals to two opposite interior angles, right? Now, if I were to draw a rough sketch here, if this is an exterior angle, this would be equals to these two opposite interior angles, right? You exclude that angle right over there. So as a result, my O1 in this instance is going to be equals to angle R as well as angle P. Why? Because this is an exterior angle of a triangle. So here I'm going to use O1. This would be equals to angle R plus angle P, and exterior angle of a triangle, right? As a result, my O1, it will be equals to, remember, angle R is X, angle P is X, meaning that my O1, it will be equals to 2X as a result, right? So now, also, if you were to apply the very same concept in the other triangles, there's no need for you to do the very same step in the other triangle, which is triangle Q, P, O. So there's no need for you to show the same workings in the other triangle. You could just say, similarly, right? So simi in triangle. So the other triangle is triangle OPQ. Similarly, triangle OPQ, this O2 right over here, it's going to be equals to 2y, because remember this angle Q would also be equals to y, right? Similarly, O2 is going to be equals to 2y in the other triangle. As a result, O1 plus O2, this is equals to 2x plus 2y. Now, if I take out 2 as a common factor, remember my O1 and O2, same, let me just add them here. Remember my O1 and O2, right? These two angles combined, they would make my angle ROQ, right? So I could just write that as ROQ. So here, ROQ, it will be equals to 2x plus y. This is if I take out 2 as a common factor, all right? So it will be equals to 2x plus y. As a result, remember, we said this here, we must let it be equals to x. This here, we must let it be equals to y. So when we're saying that this angle here, right, which is O1 and O2, it will be equals to 2 multiplied to x plus y. This simply means that this would be equals to 2 multiplied to this whole of angle P, all right? So now here I can say, okay, therefore, ROQ, it will be equals to, basically you're solving, you're required to prove, right? 2 multiplied to P. Because remember, your x and y both combined, they would make your angle P. And this would be your final answer.